We're on part 4 of our chapter 5 microscopy lab discussion. So we've been through the parts of the microscope, we've been over how to calculate total magnification, we've described how to increase resolution and contrast. So now we're just going to walk through how we're going to use the microscope, and we're using a prepared slide of, I believe it's Spirogyra. So this is a photosynthetic eukaryotic microbe. They're big and they're beautiful. These prepared slides, they have a really thick cover slip, so we always have to be careful working with thick cover slips that we don't damage our oil immersion lens. So just a couple of things. When we're bringing our microscope to our bench, we always want to use a two-handle carry. We never want to swing the microscope. The ocular lenses can fall out and that can cause a lot of damage, so we always use a two-handle carry. The A&P instructors taught me a lot about protecting our microscopes. Because the microscopes are heavy and they have little rubber pads on the bottom of the base, if you set your microscope down and then drag it over the bench top, the little pads will stick and it will cause the microscope to bounce, destroying the lens and mirror system. So to reduce that friction, simply put a piece of paper down on your bench, like so, and then set your microscope on that paper, and that will reduce friction. So now you can make slight adjustments of where your microscope is without it bouncing around and destroying the lens system. A big safety hazard we have in lab is that the electrical cords, people often let them loop down almost like a lariat, and people can trip in those loops of cord. They can hurt themselves, they can hurt the microscopes. So again, the A&P folks taught us if we just wrap the excess cord around the electrical outlets, that's going to really reduce the tripping hazard of those electrical cords. Okay, so when we first get our microscopes, we want to clean it. And with the lenses, we only want to use high quality lens paper for cleaning our lenses. Okay, so your locker should have lots of lens paper. We'll have lots in the front of the lab. We want to make sure that we never ever use chem wipes. Don't use chem wipes to clean your lenses. Don't use Kleenex. Don't use paper towels. And the reason for that is only lens paper will avoid scratching our lenses. So again, you guys, we always want to make sure we only use lens paper. So we presume that possibly our colleagues that used the scope before us forgot to clean the lenses. So we're going to take a piece of lens paper, and we want to make sure that we clean the ocular lenses. There can be grease from eyelashes, maybe eye makeup that gets onto the ocular lenses. All right. And then in addition, we want to make sure that we clean all of the objective lenses. And I'd recommend starting with the scanning lens. Oops. All right, and then we're going to work our way around to the low power lens, the high power lens. Always check to see if by accident oil's gotten on the, the high dry lens. So we check to make sure there's no oil, right? And if there's no oil, then we're going to go and we're going to clean the oil immersion lens. And very often by accident, folks have left oil on the oil immersion lens, and that's really bad. As in some microscopes, the oil can seep through the cement holding the objective lens in place, and dried oil causes the image to appear fuzzy, not clear. If the oil gets on the inner side of the lens, we actually can no longer clean them, so that objective lens is done for. Okay, so again, we've cleaned our oculars and our objective lenses. You can see I already have my microscope slide in position with a slide clips, and hopefully your colleagues have replaced the microscopes correctly, meaning that the scanning lens should be in position. The stage should have been lowered all the way down, right? The variable light controller or rheostat should be on 1, the lowest setting. And this one we're going to have to adjust back to 1, all right? And we want to make sure that our specimen is centered over the hole in the stage. So we use our mechanical stage adjustment knobs. These we'll recall here and here to center our object. Since in most of our labs we're going to be looking at mostly stained bacteria, I'm going to make sure that my substage condenser is elevated by raising the substage condenser. Okay, I'm going to turn on my light switch here. Okay. And what I'm first going to do is, using coarse focus, I'm going to raise the stage looking from the side as far as possible. Again, and I'm not looking through the oculars, I'm looking from the side. I want to make sure that the stage and slide aren't going to ram into my my scanning lens. Now, the reason we do this is for the safety of the slide. Okay, so we're going to focus by looking through the oculars, and we're going to focus by slowly lowering the stage until the specimen comes into focus. So we'll just pretend that I'm looking through my oculars right now. I'm going to lower my stage, until my microbes come into focus. Right, so I can make some observations, maybe make some diagrams. I definitely want to look at more than one field of view, so I want to move the slide around. And then when I'm ready to increase magnification, looking from the side, I'm going to rotate my turret, my revolving nose piece, until my low power lens is in place. I'll look through the oculars. Now, in theory, since these microscopes are called parfocal, once we have a specimen in focus with one objective lens, it should remain in focus once we switch to another objective. With our scopes, they aren't perfectly parfocal, so when you move to your low power lens, it'll probably require additional adjustment, and we could use either coarse focus adjustment or perhaps fine focus adjustment here. And then once we've made our observations, we're now ready to move up to our high dry objective lens. One thing I forgot to mention, that as we're moving from lower power to higher power, we would also be increasing the variable light control, or rheostat. We want to increase light. Okay. Now, you'll remember that the high dry lens and oil immersion lens, they are our longest objective lenses. So we have to be really careful that as we're rotating them into place, that they aren't actually making contact with our glass slide, and especially a slide like this that has a really thick cover slip. So I'm very carefully, gently, going to rotate my high dry lens into place. I do it slowly to make sure that it doesn't literally crash into my microscope slide. And it didn't. But the question now is, which of the focus adjustment knobs can we use with the high dry lens? And you want to remember, it's only fine focus. And because these are parfocal microscopes, it should only take half a turn, at max 2 turns of fine focus to bring your specimen into focus. If it takes more than 2 turns of fine focus, and your object still isn't in focus, call me or one of our great micro tutors over to help you, because it means something might be wrong with the scope. All right? And then eventually we're going to move up to our oil immersion lens. And again, I'm going to stop the video just so I can get my immersion oil over here and be prepared for the final step using the oil immersion lens.